Hello, calculus fans. So happy that someone on the discussion board asked a question like this. It is vital for future courses that you can label a graph correctly. And so I'm going to focus on that, and then we'll finish this question. I haven't looked at this question before, so we're going to do it live. I just turned on the recording, and now we're going to read it. The region of the xy plane that's above the x-axis and below the y equals square root, and between the lines x equals 1 and x equals 4 is rotated around the horizontal. Okay, there's going to be some rotation. I don't care about that yet. I'm just going to draw a picture of the region. And then I really would like to label it. In fact, I think I'll draw it twice, since in this video I'm focusing on the labeling. Okay, so let's draw one by one the pieces. So we need to draw the square root function. What does it look like? Hopefully we know that already. If you don't know what it looks like, you just plug in some numbers. Plug in 0, you get 0. Plug in 1, you get 1. Plug in 4, you get 2. And that would be enough. Just connect those 3 dots and you would have a pretty decent picture. Okay, next. We're going from x equals 1. So here's x equals 1. And here's x equals 1. And you should take your time and make sure you have a correct picture. We're going to x equals 4. Here's x equals 4. Here's x equals 4. If we want to recap from earlier in the term, you can use x or you can use y to describe this region. You should recognize that one of those methods will be much better. But let's say we're exploring, so it's that region in between. What would happen if we label things in terms of x? And so when I do that, I draw a random x somewhere in the region, and I start to look for a pattern. And you should know how to label that, and you can test it out. Okay, secondly, if I label a random y and start walking, I encounter the region, but you should recognize that it's orange to blue. This one, no matter where I would have drawn it, it would have been green to pink. Whereas this one, it does matter where I draw it. If the y had been up here, then you're going to go pink to blue. So because of that, I would prefer not to use y's. X's would be better. So that's kind of a recap of our entire thinking. But since we're here, let's label everything. And what do I mean by that? Well, you should know that this, given an x, this is going to be the square root of x. That's what we mean. There seems to be some sort of disconnect, but if you know what a function is, y is the height. Meaning if you plug 4 in for x, this is going to be 2. It's 4, comma, the square root of 4, which is 2. That's what the function means. I think some people think of a function as just a random thing someone made up. No, you can actually plug into it. You plug in a 4, you get a 2. And if you plug in a 2 for y, you get a 4 for x. So you'd say it goes either way. Okay, so here, and then when you plug in a 1, you get a 1. But that pattern, y equals 0 up to y equals the square root of x, works over the entire region. And this length is the square root of x. So we would like to use x because it's simpler. Okay, now let's think about it in terms of y. In terms of y, how far is this? From there to there. Well, it's x equals 1. We can see that. How far is it from here to here? Well, that's x equals 4. It's 4. Okay, if you go up to this y, it's still 4, but something has changed. And so the game here, if you want to call it a game, is I give you a y value, y equals 1.7, and you have to tell me how far it is to get over there. And you can't say the square root of 1.7 because that doesn't make sense. I'm giving you a y. Based off of y, what is x? X would have to be the square of y. So again, I've tried to get you in the habit of just immediately rearranging the moment you label this y, but this is y squared. So that's it. I don't kind of know how else to say it. We really have to be able to label. And we don't want that to be a challenge. mean, when I look at this, I go, okay, this is 0 to the square root of x. This is 1 to 4, and y squared to 4. Most confusion stem from that. Back when we talked about this, you could go back and watch my lecture on 6.1, 6.2, and 6.3. I did a bunch of examples, talked through this. Okay, now back to the story. The question was asking about what? So you notice everything I just did, I didn't even think about the volume yet. Okay, so let's clean it up a little bit, because you wouldn't have drawn all that stuff. That was part of my explaining. And honestly, I wouldn't have labeled these either, because you can read those off. Okay, so if we want, now we're going to do the volume around the horizontal line y equals -3. So let's label the horizontal line y. And I'm not going to worry about making my line really accurate because it would be much lower, but I'm going to run out of space if I do that. Y equals -3. And I already know that I would much prefer to use x. And I suspect that's what part A is asking, but we'll get to that in a second. So now let's draw a random approximation somewhere in the middle. And the thing we just discovered is it doesn't matter if the approximation was there or over here or over here. Sorry, I don't know why I'm drawing so poorly. But it's going to have the same pattern for how far it is from here to there. It's going to be square root of x, and from there to there it's going to be the square root of x, and from there to there. It just will depend on x. If you then rotate that around, you should see that you get a washer. And further, you should see that this is the inner radius, and the outer radius is to the outer edge. So you get a thin washer. I'm going to erase that for a second because we don't really need it. So what we need is this. And if you ever are confused with this, just stand here on your axis and walk out. When you get to your region, that's your inner radius. That's one thing we need to label. And when you get to the outer edge, that's your outer radius. But anyways, the moment you chose you were using x, we should have written 1 to 4 dx. We should have written pi something squared minus pi. Back when we talked about this, we said if it's perpendicular to the axis of rotation, if it's a cross section, however you want to say it, it's going to be this washer idea. Then we have two things to label. The inner radius, which is how far it is from here to here, which is just 3. And the outer radius, which is how far it is from here up to the function. And we already know from here to here is square root of x, and here to here is 3. So it's 3 plus the square root of x. And we talked about how if it had just been going around the x-axis, so how would this be different if you were going around the x-axis? It would have looked like this. And it would have been a disk. So if you change the line to y equals, it just makes it so the radius of the inner and outer radius is 3 times as much. Anyways, evaluate this integral. Okay, let's do that part. So we have to expand. Let's view and expand. And then we'll get to part B. I know if you're waiting for part B, just skip ahead to that part. So we're going to have pi. You're going to go from 1 to 4. There's no way around it. You'd have to monkey face this out. Plus 6, the square root of x, plus x. I just expanded that. There's the middle term, which is 2 times that product, minus 9. So the 9's cancel, so it's better than it initially looked. And actually, we're ready to integrate right now, so let's just integrate. So this is 6x to the 1/2. Excuse me, so it's going to become x to the 3/2. There's going to be a 2/3. There's going to be a 1/2 x squared from 1 to 4. This is going to be the 6. We'll cancel, make it a 4. So it's going to be pi times 4 x to the 3/2. Maybe I'll take a moment. Plus 1/2 x squared from 1 to 4. And then when you plug in the 4, you get the square root of 4. So it's 8. So 4 times 8 plus 16 over 2, which is 8. Minus 4 plus 1/2. So we get pi 40 minus 4 minus 1/2. So we get pi 36 minus 1/2, which is Twice 36 is 72. So 72 minus 1 over 2. 71 pi over 2. Apologies if there's any mistakes in there. Please let me know. But let's get back on to the next piece. So the question was about part B, set up using shells. Now shells is the one we didn't want to use because that forces you to use y. But we already talked about this at the beginning of this video. So let's talk about if you did the volume using y. So if you're using y and you're rotating around, it's going to give you a shell. If you do an approximation right here, let's do a little eraser here. Sorry if you were looking at that, you'll have to go back. And we're rotating around this line, y equals -3. That's going to give rise to a shell. So now we're looking for the radius, and that's the interesting part, and the height. And unfortunately, the height is changing. And it changes at this value, which is y equals 1. So from 0 to 1, one thing happens. And then from 1 to 2, another thing happens. How do I know it's 2? We already had this up here a moment ago, but I plugged into my function. This is 4, 2. This is 1, 1. So the pattern changes there. And then it's going to be 2 pi times the radius times the height, dy. And we're going to add those together. Okay, what's the radius? The radius is this, once again, is 3. And this is y. So in both these cases, the radius is 3 plus y. And back when we talked about this, I noted that what changes is the radius. We added 3 to the radius in both the problems. So that's the only thing that really changes when you have a line like this. Okay, the other pieces. Now we need the height. Now from 0 to 1, the height is 4 minus 1. It's 3. And then we need this length, 4 minus y squared. Now, if you were taking this final and you had extra time, which students often do, you could calculate this out, meaning you could compute this and compute this. I know that would take a while, but if you have an extra hour, it's actually not too bad. The first one's pretty easy to expand. The second one's a little more. And if you get 71 pi over 2, then you know with almost certainty that you're right. So it doesn't hurt to do that if there's time. If you don't ever, if it doesn't come out right, then I guess you don't know if it's your computation or your setup. But there is this potential that little investment of computation time, 4 to 5 minutes, could confirm to you that you're right. And then you can move on to other things. All right, hope that helps. Let me know if you